Good morning once again. Now we started our next session. Dr. Prasenjit received the BTech degree in Computer Science and Engineering from the West Bengal University of Technology, Kolkata, India in 2010, and the MTech degree in Computer Science and Engineering from the National Institute of Technology, Durgapur, India in 2012. He was an associate inventor with Nivio Technology, Gurgaon, India in 2012. He was a hardware graphics designer at Intel from 2017 to 2018. He received his PhD degree in Computer Science and Engineering from the NIT Durgapur, India in 2018. He was an associate professor in Computer Science Engineering at Coach Bihar Government Engineering College, Coach Bihar, India. He joined the National Institute of Technology, Rourkela, Odisha, India as an assistant professor in the Department of Computer Science in 2023 and is currently working. Sir, over to you.
Okay. Thank you for this warm welcome. So let us start. So may I share my slide? So in this class I am going to discuss various learning methods in AI or machine learning. So is there any way that I can control? Yeah. So in this class I majorly talk about different learning approaches in AI. I will start with statistical learning, then rote learning, advice based learning, problem solving, example based learning. So let us start. So majorly here our concern is that why do we need to learn? The first question, before knowing what are the learning strategies are there and all, we need to know why we need to learn. So overall lecture agenda will be like fundamental of machine learning, like what is machine learning. So there I will talk about like why learning is required at all and what are the ways to learn, that is paradigm of learning. Then I will talk about various learning paradigms, like learning can be data driven, so from data we are going to learn. The learning can be based on our own previous experience or prior knowledge, and it can be reasoning based. And finally we have to see that can we integrate multiple learning paradigms for a single problem. So what is learning? So learning is the process by which an AI system improves its performance through a task. So if I have to do a certain task today, if I do that particular task after 1 year with similar efficiency of performance, then I am not learning from my experience in between that 1 year. So every time when we do something, the next time we are supposed to do better based on the current feedback. So that is what mean by learning. Now in AI, artificial intelligence, learning means modifying, like now how to improve. Like a model needs to improve its internal architecture. So if this architecture do not work well, then I need to change my architecture. Like in my slide also I can say, if this slide is not good enough to teach everyone, in that case I need to change the orientation of the slides, change the content of the slide. So this is the architectural change. Similarly rules, maybe the way I am discussing the things, I need to change the way of it. The parameters, the tone by which I am talking to you, I need to change it. So various things I am going to learn from this talk based on the participant feedbacks, and next time I should come up with a better delivery. So that is what should be my agenda. So that is what learning is. So learning system is able to adapt to new situation. Now suppose I am always good at teaching the UG students. Now if I have to teach the same thing in a new environment, maybe lot of faculties are there, I may need to change my strategy of teaching, or I may need to change my strategy of delivering a particular thing, because the audience may having a vast, huge amount of knowledge with respect to UG students. So they know a lot of, and we need to know what they may be like want to inquire, and accordingly I need to frame all the things. So that is why it needs to adapt to new situations. I am talking about with respect to my talk. It can be conveyed into other domain as well. Now improve accuracy over time. Like I said, the way I am giving talk today, that needs to be improved in the next time. So it must improving, continuous improving process, and generalize from the past experience to unseen sample. So that means to say, let me talk about like I'm very good at suppose detecting a mail is spam or not. Now next day the attacker is also improving, or those person who are supposed to spoof us, they are also getting intelligent day by day. So next time they may come up with a mail that mostly look like a normal mail, and they may click that you got it, like earlier they used to say you got $10 million, click on this sign to get it, or click on this link to get it. And that we know that if this $1 billion they are providing in a mail, and they don't know that, we don't know that person, and they are coming from a different country as well. So it is very unlikely that someone is going to donate that amount of money to me. So I can, from that word like 10 billion or $1 million, the recipient, there was never any email communication with the sender. So in that case, we can easily detect that is a spam mail. Now if I change it to, like I have trained my model that if this situation, like it is talking about giving me money in dollar, where I have no communication with that particular person, there is a possibility that it is a spam. Now let me change the scenario. Suppose someone from India sending you a mail that we pass you a certificate of faculty development program. You just click it and collect it. So most of us may fall into that trap, because we are the faculties, we assume that we are going to get a certificate and just click it and we are going to get it. But this may not happen. Na? So if I know that I have not attended that FDP, I am never part of it, so how it come supposed to, they are supposed to pass me a slide. So I can check who is the emailer, and I can inquire my colleagues and other measures we may take to before clicking on that link. So this is what, like, we need to adapt or generalize ourselves from the past experience. Past experience may be different. The current situation may be a lot more different from the past experience. But still we need to work well, or understand well, and react well. So learning is a core requirement for building intelligent autonomous system. Now you, instead of you are doing all those research, we put some software in my email service, maybe add-on third-party email service I am supposed to use, that use AI, and that going to check whether that email is spam or not on behalf of me. So that particular software which is there in my email, that needs to be reliable, and that needs to judge properly whether a mail is spam or not. And in that case, false positive is very dangerous. Like suppose if it failed to detect an email as spam, it is okay. But suppose the email is very important and it assumed that it is a spam, and it go into the spam folder and you just miss that email, it can trouble you more. So that is the situation of like false positive. So that is highly risky. in case of email or any other situation where we should not wrongly label something as negative or dangerous in this mail case. Similarly, the other situation I can also convey, like suppose in a medical case, I go to a medical test and the doctor said that I may be having a particular disease. Maybe doctor say I am diabetic. So in that case, and suppose I am not a diabetic. So situation say, earlier it was a male and the mail was normal mail, but the system identified it is a spam mail. So it put it into a spam folder. I did not see the mail. May have been the email may have come from a very higher authority, very important or urgent mail which I have missed. That will put me a lot of trouble. That is false positive. Now I am going to talk about a different scenario. I went to a medical unit, a diagnostic unit. They do a test of mine. They said I am diabetic, but I am not diabetic. So they are mistakenly or falsely making me a positive with respect to diabetic. So same scenario. Here is it dangerous? No. Because if they detect me as a diabetic, I may do a retest and next test it may be concluded that I am not diabetic. We do medical test multiple times. Now, if we come up with some rare disease or not a good disease, we need to confirm. But suppose I am diabetic or maybe having some more severe disease and it got not detected by the AI tool, whatever from that blood that sample it is collecting and deciding, it said that you are not diabetic or you are not having that rare disease. In that case, it is going to harm us more, isn't it? Because we know it and we don't know it that we are having that disease and we are not taking measure of it. So it is going to harm us more. It is called false negative. So these two are very harmful situations. So if something is dangerous, we need to identify it. If we ignore it, that is going to harm us. So there are two concepts of false positive and false negative, and depends on the scenario which one is more severe. And due to these certain factors, we must keep on learning ourselves. Now let me go back to the next slide. So what I am talking about now, let me go to the second slide. So why do we need to learn? Real world problems are complex, dynamic and uncertain. Like we don't know lot about the problem. The problem is day by day is changing. And the problem is very complex. Like it is not like ES rule. The student got more than 60, the grade will be maybe C. The student got less than 60 and more than 50, the grade will be D. Rules are very simple. But suppose rules are very complex and rules are fuzzy. So if the values lies between this and this range along with the certain scenarios and certain cases, then I am going to give that student a particular grade. If I make the situation complex, now the rules may change. Today the grade for C may be 50 to 60. Next month it may be 55 to 65. So that is rules may change and rules may be uncertain also, fuzzy also. So in that case the learning become difficult, and in that case you cannot just go with the if else condition. Like in any programming language or any language, you learn a certain set of rules, like grading. There are certain rules. If the marks within that if else loop, we are going to put that grade. But in a real world the situation are not so simple if we cannot put everything in a if else condition. So writing a fixed rule for every situation is not scalable. Learning allow AI systems to adapt to new and unseen situations, improve performance through experience, generalize from the past data and handle uncertainty and the noisy data. Suppose I am having a medical image, and in that case I need to detect whether that image having a tumor or not. Now tumor may be at a in only few pixels in that image. Only in a few pixels in the image the tumor is present. So if I and medical images are always a noisy image, because it comes from certain sensors, and the sensors may not be good quality, and sensors quality also varies, like in which hospital which instrument is taking the measure, that is also important. So in that case, the data which you are getting, that data may be noisy, the data may contain uncertainty, and from that we need to make the right call. So in that case also if else may not work. So maybe the image, the tumor, those pixels which are representing the tumor, that may be having some grayscale value. Now if I say that if the grayscale value is only more than 150, then only I will decide that this pixel contain the tumor. But reality, the image may be noisy, and maybe the tumor cell which is represented by a pixel, that may be having a grayscale value of 120. So I cannot every time say if the value is higher than that, then only that particular pixel is representing the tumor cell, or tumor cell. So fixed rule will not work. So AI system learn in different way depending on the data availability. Now we cannot learn everything if we do not have the data. So it depends on the how we are going to learn, that many a times depend on the amount of resource we are having. Suppose I want to learn quantum computing, but suppose I do not have a good guide, I do not have good materials with me, or tutorials with me, books with me. So in that case, even I need to change my learning strategy. Based on the situation, we need to change the strategy, the way we supposed to learn, if we wish to learn. I want to learn quantum computing, I do not have any guide. So in that case, I need to look for the other opportunities to learn it, if I want to learn it. So that is like how you are going to learn, that depends on the availability of the data, prior knowledge on the data, nature and the complexity of the problem. So I want to learn a very complex problem. Maybe I want to learn quantum computing. And in that case, suppose I know nothing about the quantum computing. I don't know anything about the quantum computing. In that case, the way I will learn, I will think about my strategies to learn that course will be lot different compared to if I am already having a knowledge of quantum physics. So that is why, based on the problem, learning strategies supposed to vary. And based on that, these 6 learning strategies I am going to talk about one after another. First is the statistical learning. Statistical learning, by statistics we all know that we are supposed to have a lot of data and we need to learn the pattern from the data. Now if the data is like a set of array values 1, 2, 3, 4, 5, 6, 9, 10. So if I am having a set of values, what first statistical term comes into our mind? Can anybody respond? Like, what is the most basic parameter in a statistics? Sample, yeah, because we cannot take all the data, so we have to take a few, and based on that sample we need to make the judgment on the whole population. Now what are the parameter in the statistics in that sample we need to take? The most basic parameter in the statistics, most basic parameter. Like if I say that if I have to prediction about all the people in this room, in that case suppose I want to predict what is the average age of all the participants in this population or in this sample. So mean is average, isn't it? A weighted average. So mean is a measure which is going to talk about that this is the audience. So if someone asks me what was the audience of your talk, so what age group the audience from in your talk, If someone asks me, my question is supposed to, like in a single shot, they are around maybe 30 or they are around 32. So that means the value is 32 and there will be someone more maybe close to 50, someone maybe close to 25. I should say average age is maybe suppose 35. In that case, someone from 50, someone from maybe at 25 or 20, and in between there. So this is the spread. So how much value is varying with respect to the mean value, that is standard deviation or variance. So these are the basic core properties of the statistical learning. So can we use that type of concept to learn something? Let us see. So statistical learning is always data driven. If you do not have any data, you cannot come up with any statistical decision. So statistical learning is a data driven learning approach based on the probability and statistics. Probability is what? Suppose okay, random guess, if I see into this room, so there may be only 6 female candidates and maybe around 20 male candidates or 18 male candidates, roughly speaking. So in that case, the ratio is what? I can say like 1/4 is the female, 3/4 is the male. So 0.75. If I ask that if a new participant come into this room now, if a new participant come into this room now and someone ask me what is the chance that the new candidate will be male or female, my default guess should be male, because the maximum chance 3.75 probability is there that the next person which I don't know must be a male. That is our previous knowledge or prior probability. So statistics and the probability are the core component of statistical learning. So in this case, I am a robot. A new participant is going to come in this classroom or in this FDP, and someone asks me as a robot, my answer will be the next person who is going to come is a male. So that is how statistical learning works, based on the probability theory and the statistics. Now learn pattern and the relationship directly from the data. Explicitly model uncertainty and the noise present in the real world data. Use loss function to measure the prediction error. Objective is to generalize well on unseen data. So what are those terms signifies? So real world data, suppose I don't know a function, but I know, like I may be having a table where a set of x values are there and set of y values are there. So I am having an Excel sheet maybe where 2 columns are there, one with respect to the column x, another with respect to the column y. So there is a pair of values x and y. Now next time if I give any x value, I may ask you what will be the corresponding y value. Suppose x value is 1, 2, 3, 4 and y value is 1, 4, 9 and 16. So we can understand the underlying relationship between x and y is equal to x square. So if I feed x as 5, output supposed to be 25. This is a simple case. So in real world we always have the data, but we don't know how the data is related to each other. So in my previous example, y is equal to x square, x is an independent variable and y is a dependent variable whose value depends on the value of x. So real world also we need to draw some inference, and for the inference we need to know the relationship between those features. Suppose I need to know, suppose suppose in this room suppose I know the height of each persons and weight of each persons. Now if I ask if the person's height having something like 5 feet 4 inch, in that case what will be the ideal weight of that person? So ideal weight may be 64 kg. So I am putting the condition that in this classroom I know the height of all the people, I know the weight of all the people. Now someone asks me, if a new person comes with the height 5 feet 4 inch, what will be the weight of that person? I will just take the statistical measure and say this will be the weight of that person. So now first time my guess will be wrong. Next time, and I said suppose the weight will be 60 kg, but maybe the weight is supposed to be 64 kg. So what is my error? Error is predicted value 60, actual value 64. If you take the difference, 4 is the amount of error. So now I will tell the system this is the amount of error in your decision. So accordingly you change your learning strategy and other things so that next time the error amount is less. So next time when the person will come with height 5 feet 4 inch, my guess should be more closer to 64, because 64 is the ideal value or true value. So every time whenever I am feeding the data, I need to measure the error and I need to keep on reducing the error. Now I am not going to detail into the maths because that must be, as I have seen the FDP curricula, so it will be taught by in other segment by other faculty. So I am not going into that. But overall, end of the day, we need to keep on minimizing our error, and to minimize that error, we know that calculus is there. So first order derivative need to be 0, second order derivative should be after a certain point positive, so that means that is a minimum point. So whatever error is there, you have to differentiate with respect to the parameter, and first order derivative you need to take the 0, and you will get some parameter value for which that first order derivative of the error is 0, and that is the optimal parameter value. If you get to know that value, you can easily predict any dependent variable given on independent variable. So that is the concept of linear regression, logistic regression. Bayes classifier is based on the conditional probability. Bayesian network is a neural network based on probability theory. Support vector machine is another statistical. All other statistical methods which I supposed will be taught. Okay, in that concept, I would like to ask one question to the audience: that do you people know these methods? Anyone? Or these are completely new to you? Completely new for everyone, no? So in that case, it will be taught. There are a lot of strategies. So there is a term like regression. Regression means you need to, in a most simplest words, regression is a function approximation. That means we have to predict the output, and that output is some real value. So if I have a set of real values of x, set of real values of y, if I give any new x value, you have to predict the new y value, where y value can be any real value. That means fractional value it can have. So that is the problem called regression. Now there is another type of problem there, that is called classification problem. What classification? You got an email, you need to detect which class it belongs to, whether it belongs to the normal mail or it belongs to the spam mail. So that is a classification where you are having a sample, you need to label it with some class. That is classification problem. And another problem which I am talking about, that is a regression, where you need to come up with the output that is some real value. What will be the weight if that is the height of that person? That is the first one. Linear regression solves the assume that output is a real value, and whereas logistic regression, it is a classification approach where we need to label the new x sample into spam or not spam or any other classification group. Naive Bayes classifier, it can be used for both regression and a classification task. Bayesian network can be used for both regression classification task. Support vector machine majorly used for classification task, and accordingly there is a component of the support vector regressor. Support vector regressor is used for the regression task, but conventional term is SVM. So if people say can SVM do both the classification and regression? Our answer should be yes. But for the regression, we use the term support vector regressor. These are all statistical methods. Now supervised learning. Whatever previous example I have given, okay. Do you people know what is supervised and unsupervised learning? Okay, very good. So in that case, it is good that we know the relation. So we have a set of x values and all the x values are associated with a set of y values. But we don't know that f. We don't know the relationship, how x is related to y. That we don't know. And in that case, whenever I feed some x value, it will predict the model, an AI model or machine learning model. If I feed an x value, it will predict the y value. That prediction may not be the correct prediction. So whatever the predicted y value, that I need to take the reference with the true y value. And the difference between them is going to give us the error. Now that error we have to minimize, and when the error will become 0, in that case I will always predict the correct y value. So that is the task of that is the objective of the supervised learning, and there are two type of learning is there: classification and the regression. Now unsupervised learning, as it has been taught, can anyone tell me what is an example of unsupervised learning, a real world scenario of unsupervised learning? And it would be nice to get a real life example of supervised learning. Just one real life example where we apply supervised learning, and one real life example. How could you just explain in simple terms? Okay, yeah, right. So you mean to say, if robot sees this device, the robot will say this is a mobile phone and this is a supervised learning. Because I have already trained, if it look like this, if I can click it, if I call, if these are the features available with it, it is a mobile phone. Yeah, that is a right answer. Now my question is, give me a real life example of unsupervised learning. Okay, unsupervised, any guess? Unsupervised, it has been the discussed earlier, no? So it has it been discussed earlier, unsupervised learning? Oh, so just give me one real life example where we apply unsupervised learning. Yeah, please. Yeah, weather broadcasting, forecasting. How is it unsupervised learning? How it could be? But unsupervised and supervised means some supervisor is there to guide us. So unsupervised learning means when during testing anything can be done. During testing we are not. In exam hall, when we come with the come to prepare for the examination, that time only question is given, we have to write answer. In the exam time nobody guide us, na? So that is testing. Testing time, whatever you will do, that is do. I go to a medical diagnostic center, they take my blood sample, they come up with some diagnostic report. That time they did not reevaluate and trying to minimize the error. So testing, only training time we learn, and that learning, if it is supervised by something, then it is supervised learning, mostly labeled data. If it is not supervised by something, then it is unsupervised learning. In case of weather forecasting, like this scenario, when we train, during testing we are forecasting. You may ask what will be the weather temperature or rain probability for tomorrow. We will come up with some answer. There is no chance of rain tomorrow. The temperature may be around 20. But when that model was training, that time have you used any label data or not? So my model, suppose I am a robot, I need to forecast what will be the temperature tomorrow. Now you ask me, I will say temperature tomorrow is 20 degrees Celsius. But when I learn myself, have I used any label data or only the training data? What is the training data? Raw data. So like okay, each day can you explain with the what raw data, what exactly that raw data is? No, I need to know the real answer, means the real life example. So I like you ask me a real world question, na? What will be the temperature tomorrow? I say the temperature will be 20 degrees Celsius. Now my question is to you that when I was training, that time what are the things feeded into me? What are the real world things feeded into me? I am not asking any theoretical answer which can be written in answer sheet. I want a real data. So some information may be feeded into me, like maybe today is the date, today is the maybe for the next year 2026, today may be the 34th day, or maybe I should say that maybe it is 35th day of this year. So if I have to predict the weather for the tomorrow, temperature for the tomorrow, I must have feed that in day 1 this was the temperature, day 2 this was the temperature, day 3 this was the temperature, and along that thing is look up something is there, pair is there, and now they are asking what will be the temperature at the day 35. So for all those dates, what was given? Temperature. Now in my question, if I ask you that question, what will be the temperature at 35th day? So what is my input? Temperature or the day? And in that lookup table, I was having day and the temperature. So now I am providing what? Day or temperature? Day. So in that case, what is the independent variable? Day. What is the dependent variable? Temperature. So now tell me, when I come up with the answer, what will be the temperature tomorrow? Was I guided by the dependent variable temperature earlier or not? So in that case, it is a supervised learning, because the temperature, which is a label which has been guiding me to make this judgment of today. But unsupervised learning is what? Suppose, okay, suppose there is a child, and to that child I gave two different type of fruit to that child. I did not say what type of fruit it is, what fruit name is. I give two fruits to that child. Now the child need to judge whether those two fruit are of same category or different category. How they are going to judge it? Based on the shape of the fruit, based on the color of that fruit, based on the size of the fruit, that is shape, based on the taste of the fruit, based on the texture of the fruit, if he or she can touch it, texture of the fruit, like whether it is rough, smooth or anything, and based on that, will the child be able to decide whether they are same or not? They will be. Have I said that maybe suppose the first was apple, second was orange? So have I told that child that first fruit is apple and the second fruit is orange? Was the label given to that student? They are only having the X, and based on X is a fruit, and they need to make the judgment whether those are same or not. So you are having a lot of X independent variables, and you need to check whether those variables are same category, or I should not use the variable term, I should use sample. So I have given a lot of samples, and those samples have no label associated with it. If I give one apple and label it with this is apple, and I give another, suppose there is an image of apple and there is a tag, this is apple. There is an image of orange and there is a tag associated with this is orange. And in that case, if I show any one of these two fruit to that child, the child already it is not memorized. The child already have some learning, I should say. And if it look like an orange, it will say it is an orange. So it is a supervised learning. Now in the second example which I am currently discussing, in that case two fruits has been given to that child, and based on the similarity dissimilarity they are judging whether they are same or not. But the child will only able to say they are same or not. They cannot say whether they are apple or orange, because that label information is not given. That is the unsupervised learning. In an unsupervised learning, we do not have the label data, and we can only group together similar item and separate the dissimilar items. So that is why the clustering. Now anomaly detection. So there again you receive an email, or in email sense I am talking about. You receive an email and you need to make the judgment whether the mail is normal or spam. So it is not a classification task. The spam mail can be any kind. It will be like out of universe, out of the universe, it can be anything. But you know what the normal mail is look like. So you know how apple is look like. You may have never seen any other fruit. So if it is having all the features of an apple, it is apple. If it is not having the feature of an apple, it can be any other fruit. I will group together. These are the apples is a group, and these are the other type of fruits. That is the anomaly detection analogy. So if anything is abnormal, then that is not normal, and abnormal can be rest of the universe. So that is another example of unsupervised learning. Dimensionality reduction. Okay, suppose we are having a sphere, a football. Football is a 3D entity or 2D entity? 3D entity. So now what will be the 2D projection of this football? Circles. So that is the concept of dimensionality reduction. Is it using the label it is football or rugby ball or anything? No. Rugby ball it will be ellipse. We are not using any label. So that is another use case of unsupervised learning. Sometimes data are very high dimensional in a medical image. Suppose we are having some image of 30 by 30. 30 rows are there, 30 columns are there. This is the resolution of the image. How many in that case feature is there? Features, each pixel is a feature. So 900 features are there. Now let us consider a 4K image. Suppose it is having like 2000 into 4000 pixels. So it may be having 3 million pixels. So in that case, a particular image having 3 million pixels, and there is another image which is again having 3 million pixels. If you need to compare these two images, how many like Euclidean distance we need to compare? 3 million, which will be very complex. And in a real world, if I need to face recognition or anything, we need a huge, maybe 10,000 images. In that case, it is not feasible computationally, and mathematically also it can be shown that it is not feasible. So in those scenarios we should reduce the dimensionality of the data, because if the data is low dimensional, we can visualize and it will be computationally efficient, it will be mathematically more solvable, and it is easy for us visualization. If suppose I am not getting the pattern of the data, I am not able to understand what is the pattern is there in the data, because data is very high dimensional, 5 dimensional, or maybe 20-30 features is there. We cannot say that two features are same or not, but if we can map it into 2D in XY coordinate graph plot, we can easily see how they are similar or dissimilar. So that is why dimensionality reduction is another helpful thing. So statistical learning advantages is what? It learn pattern automatically from the data. So without data it will not work, as simple as that, because statistics comes only from the data, probability only comes from the data. Now handle uncertainty and noisy real world data efficiently. It generalize well on unseen data. If you know the pattern, you can make a better judgment. Strong mathematical and theoretical foundation, means all the models in machine learning or AI, whatever having that statistical background, they are fundamentally clear. Like SVM or logistic regression and all. Now disadvantage, it requires huge amount of data for good performance. Now if I brought a robot that has not learned on any data, it cannot perform well if it is using statistical approach. Training can be computationally expensive. It need a lot of training and it keep on increasing as the size of the data increases. Now performance depend heavily on the data quality and the feature selection. Like you are having 10,000 features in your data, but you can proceed with only 10 data. So from 10,000 data, if you want to use 10 data, you have to carefully choose all those important 10 data, 10 features. So that is a difficult task. And risk of overfitting. Okay, is overfitting things discussed? Okay, so overfitting means it works while training, but it not working well when we are testing it. Now rote learning. What is rote learning? Nowadays, at least the new generation people lot of the time use this term. We don't want rote learning. Rote learning means memory based learning. So based on a memory we are learning. So rote learning is a learning method where AI system memorize information exactly as it is given. It does not involve reasoning, understanding or generalization. So rote learning, like in a simple term, I can see, suppose I see an image, and if that image look like a dog, I do not want any argument. I want to conclude that it is a dog. It doesn't matter whatever other people are saying, reasoning and all. I will always go that if it is look like a dog, it will be a dog. So that is rote learning. The system retrieves store based system, and the method is simple, fast, because there is a mapping. So like if I see that particular example, I will come up with the same exact answer every time. If I see a dog image, I will say it is a dog. If I see a cat image, I will say it is cat or not dog. In that case, like lookup table in C language switch cases. All of us familiar with switch case in C language? Okay. So in that case, if the case matches, the corresponding block executed. These are rote learning. So in that case, there is no such understanding or learning pattern from the data involved. So it is not at all similar to the statistical learning, where we have a lot of data. From data we train. Here we have already stored input and output. If the input is closer to a sample, the corresponding output will be the output. So K nearest neighbor. K nearest neighbor is one of the famous machine learning model used in a rote learning. So like there is a two group of people. One group of people having the average age 20 years. There is another group of people where average age is 50 years. Now if a new person comes, and if that person's like if the new person comes and if the age of the new person is 25 years, which by default which class that new person belongs to? Class 1, because it is closer to the mean 20 compared to the mean 50. So whenever the new person will come from that age, I will say, suppose, let me come up with a more realistic example. The thought process of a 50-year-old experienced person in the world and the thinking of a 15-year teenager is lot many different. So if I ask you what is like thinking process of your child, which may be having a 10-12 years of age, so you will always be say that he is like this and this, which is having the thinking mentality of the 20 or 15-year teenager group. It will not having a mentality of the 50-year age group. So that is kind of rote learning. So if I ask what will be the thinking of that age person, they will say that if the person's age is this, it will be their thinking pattern. That is a rote learning. Here we are not learning from the data. We have already have some preset criteria. Based on that we are making the judgment. So as we can see, a lookup table store multiplication results like and a chatbot replying to pre-stored answers, short question answer appear in a database. Earlier maybe the chatbot having a switch case, like if you having a query related to the maybe delivery, like in e-commerce side, if you having delivery related query, press 1. If you having customer feedback, then press 2, and lot of the switch cases are there. Here also there is rote learning is only there. They are not learning based on what the customer is asking, rather they are having a lookup table, and based on that it will put into a particular category. Advantage is what? It is fast. It do not need to learn, so the judgment can be very quick. It just match with which group it belongs to, and it will make the judgment. So it is simple, it is easy to implement, and it is very fast response for known input. If the input is known, it will not take much time and give the feedback. It is useful when exact recall is required. Predictable and consistent behavior. So every time if you feed the same input, it is going to give the same output, no change, because it has memorized, and based on that only it is going to make the decision. It is not situational. Drawback: no understanding or reasoning ability. Based on the situation it cannot change, it will always give the same judgment. Cannot handle new unseen data, cannot improve over time, high memory usage. Suppose if I have to judge maybe 1.4 billion Indian people, then I have to store the data of 1.4 billion Indian people to make the judgment of each individual. So that is not feasible. So it is memory usage is very high, and error remains if incorrect. So suppose once I incorrectly label some sample, it is there in the system, and every time a similar sample will come, I will make the same incorrect decision, and it will not improve itself. So these are the drawback of rote learning. Now next category. Third category. First was statistical. Rote learning is used when we need to learn first, when we do not have lot of time to learn. That time it is efficient. Suppose that is like Bloom's taxonomy and all. Remembering is also a stage of learning. Yeah, so remembering is also important part of learning, because if we cannot remember, we may not learn. So this is like if I go by teaching Bloom's taxonomy, the Bloom's taxonomy 2 is remembering, Bloom's taxonomy 3 is understanding, 4 is applying, 5 is creating, like that. 5 is analyzing, 6 is creating. So rote learning is a second phase of learning. First phase was statistical learning. Statistical, you need a data and you need to learn. It will very slow, and sometimes it is infeasible if the data becomes infinite, too large. Next is rote learning. It is very fast, because the earlier statistical learning is very slow. Sometimes it is infeasible for a size of data. That is why people come up with a rote learning. That is very fast. Do not need to learn in the way of reasoning. Now it is having a drawback that it cannot improve itself. So third category we are coming up with, that is the advice based learning. So there is some expert which is going to give us the advice, which is going to make the decision lot more easier. So learning by taking advice is a method where AI system learn directly from the instructions or guidance provided by the human expert or someone. So if I need to get some medical treatment, I will go to, if I'm having an X-ray, I will go to that radiologist, and that person will say what are the issues I am having in my X-ray. So this method reduces the need of large amount of data and the speed of learning, because the expert is going to make the judgment without reading all the data and all, because that expert having knowledge related to this. So systems performance strongly depend on the quality and the correctness of the advice. Now suppose I am a fake radiologist and I come up with a fake answers, then the patients will be in trouble. So lot of the things depends on the expert. If the expert is wrong, your overall judgment will be wrong. So it is having a dependency on the expert. So model like rule based learning, expert system, production if then else rule, they use the taking by advice learning. So like in a doctor, so these are the symptoms, like I go to the went to the doctor, give my details like I having maybe red eyes, I am sneezing, and maybe running noses. These are my syndrome. So doctor will say you may be having a cold, take these antibiotics and other painkillers, and you will be okay. Now there may be other reason also that is leading to these syndromes, and I may need to taken care of by the doctor in a different way. So it is again on the, like, why we do want to go to a good doctor, because they can analyze the symptoms more carefully and curatedly. So that is the learning by taking advice, where the expert is very important. Now if I can, or if we can make an AI system or a machine learning model that can make the as good judgment as that doctor. So whatever the doctor knowledge he is having, if we can put into the AI system, that the AI system can make similar decision based on the situation. It is highly used in expert systems. So advantage, reduce the need of large training data, because expert already having the knowledge. Faster learning using expert knowledge, it do not need to learn from the data, it already having some knowledge. Easy to understand and explain the decision. Suitable for critical application like medical, legal and industrial. If I need to have any legal advice, I need to go to a good advocate and all. They can give me good advice based on their expertise. But limitation is what? Strongly depend on the quality of the expert. So if the expert quality is poor, answer will be poor. Difficult to acquire and update expert knowledge, because for some robot to be expert at that level, it needs a lot of time to groom, and that is one drawback. Limited adaptability to new unseen data, because as the expert having some prior biasness, it is not easy to change. Now not suitable for highly dynamic uncertain environment. If environment is very quickly changing, it will not work, because the expert will stick to his reasonings, and it is not easy to change his reasoning based on one or two samples. He will just say it is outliers or these are exceptions. May fail if the rules are incomplete or incorrect. So the expert, if the expert having some wrong assumptions, it will always be wrong. Now fourth category, the learning by problem solving. So okay, let me come up with an example. Like, okay, suppose I am a robot. I am standing here and I need to get out of this room. So firstly I will go in this direction, I will just stuck at that wall. I will go in this direction, I may stuck before this glass. If I go in this direction, I may stuck in front of this pillar. If I go in this direction, I may go in the direction of the presenter screen. So Now I can make a judgment that these are not good possibilities. But if I go in this direction, I am closer to the door. If I am going in this direction, I am not closer to door. As much as there is no door that side, I cannot see. So I make an action, and that action leads to some reward. So I go that side, someone say, very good, you are close to the door, try again, you are getting closer to the door. So someone is advising me. If I go in that direction, they may slap me. Why you are coming this side? You are not supposed to come this side. So there is a punishment, or I should say penalty, and the reward system is there. So there is no one saying that you are 10 meter away. Like if it was supervised learning, they will say, if I go this side, you are just 10 meter away from the door. And you are 20, if I go that side, they will say you are 40 meter from that door. That exact value they are not going to provide. But they are going to assisting me that if you do this task, good, it has been done correct way. If I do some other task, they will say it has been done in a wrong way. So that is the learning by problem solving. So the more problem you are keep on solving day by day, the thinking, like we get to knowledge that these are the right way of doing and these are the wrong way of doing. That is the, so you need a huge amount of data or experience based which you are going to get the expertise. That is the learning by problem solving. Now let me read through the slide. Learning in problem solving occur when an AI system improve performance while solving the problems. So you keep on solving the problem. I am a robot, I have to get out of this room. I check with all these possibilities, and based on that I gain some knowledge. So next time it will be not difficult for me to coming out of this room if I am a robot, because I am having the previous experience. I having the idea of what is the architecture of this room. It focuses on improving the search efficiency, heuristic, decision strategy. This type of learning is commonly used in planning, game playing, organization task, optimization task, and mostly we currently in this era of 2026 we use reinforcement learning. So reinforcement learning use the strategy of the learning by problem solving, and they come from the concept of heuristic learning, A-star algorithm. So like chess, I need to improve myself in a chess game. I will play that chess game millions times, and after playing it for million times, I will get to know that which moves are leading me to the success or win, and which moves are leading me to the failure. So nowadays a robot can even beat the best world champion chess players also, because it train with the millions possibilities, and they know that which are the moves can lead to success, which are the moves that can lead to the failure. As we can see in this picture, this is the robot, and in that picture the robot needs to reach to this goal state. So it can do multiple directions. So it will go there, then it will see some obstacle, it will come down here, it will see some obstacle, it will come here, then it will make these movements and it will reach here, or it can also follow this route as well. But it needs to try all the alternatives and need to reach the final solution. That is called the search space. Now search space may be infinite. All of us must have heard the breadth first search and the depth first search. So we need to look into the search space breadth wise or depth wise, and finally we will reach the goal state. So chess playing AI learn better moves by analyzing previous played games. A pathfinding robot improve its route selection based on earlier navigation experiences. Puzzle solving like 8 queen problem or 8 puzzle problem learn better heuristic to reduce search time. What are the advantages and disadvantages? So efficiency improves with time, quality improves with time. Reduce computational cost by learning better strategies. So end of the learning, I will know a better best strategy or most efficient strategy, most cost effective strategy to reach my goal state. What are the drawbacks? Learning can be slow for complex problem. Like if the maze from which the robot needs to come out, if the maze is simple, like there are only 4-5 directions, it will be easy. If the maze is very complex, in that case it is very difficult for that robot to come out. So based on the complexity of the problem, the solution becomes lot more difficult. So require repeated problem solving experience. Performance depend on the quality of the feedback. So we sometime play the game now, we need to predict the song name or maybe movie name, and someone guide us like this is the movie name or this is the actor name or this is the song name. So if the person who is guiding me, if they are not good, in that case I cannot come up with the exact name. I forgot the name of that game, but there is such game na. So in that case also the guidance is or feedback is very important. If I go this side and someone says no, this is not the door side, this is the door size, so the maybe advice is good but not efficient, because there is a door that is maybe closer to that door. So the feedback is very important. If the feedback is not good, problem solving will not work. Yeah, exactly, sir. Random access can be done, and in that case it can lead to a better, quicker solution, because sequentially it may take a lot of time. Like in DFS, if one branch is there and it is going infinite, then I will be stuck in an infinite loop. Thank you. Learn from examples. Now I am talking about the fifth type of learning, which is inductive learning. Inductive learning, I do not have any expert. I do not have like someone to like penalize or reward me. I have a lot of data, and from the data I need to make some experience. So this type of learning is called inductive learning. Inductive learning is a method where an AI system learns general rules and model for specific examples, like weather forecasting. So I have a data of weather for each day, and based on that I may be able to expert at forecasting the weather. So it focuses on generalization, not memorization. That is how it is different from rote learning. Rote learning focus on memorizing, whereas inductive learning focus on the data. So this is one of the most widely used learning method. Neural network, decision tree, random forest, they also come into this category. And in a previous class, in initial discussion, I was talking about like x and y having, I am having a set of dependent variable y and the independent variable x, and I have a lot of xy paired values. Now if I give an x value, I need to predict the value of y in case of regression problem. So that can also be called as inductive learning. So I know that a particular xy pair, if x having a certain value, it will come up with that particular y value. Or if I feed a particular child with a set of dog images and a set of cat images, and if I show a new image to that child which may look like a different breed of dog, the child should be able to identify, yes, this is also a dog, maybe of different type. That is the inductive learning. So you learn from the examples. And in neural network or decision tree or in the random forest, we use this type of learning strategy, where we feed lot of training data to the model trains from those data, and after that it make the prediction. So it is not statistical learning. You are having some formula, and that formula you need to optimize. Here there is no formula. One example of learning which we use in here is like estimation learning. So sometime in statistical learning I said in statistical learning I said that if the problem data becomes huge, it become infeasible, because the mathematical problem, the optimization problem which you are solving, that can be solvable when the sample is limited. But when the sample having too many and there is too much interdependency among the samples or features, in that case it is not feasible to solve it. You may be able to solve it in 10 million years, but we need to answer in a feasible time. You need to get the answer in a feasible time. So in that case we use the mathematical approximation theory. One of the approaches like Newton, by scientist Newton-Raphson method. Then people come up with the gradient descent method, and then other methods, no? So currently they use Adam optimization and all. So the gradient descent approach and all, they use this type of learning. So you feed a lot of example, input and output. For after each feeding example, we compute the error. That error leads me to how to improve or tune my parameters, and I keep on feeding the examples, computing the error, and that error guiding me in which direction I need to change the parameter, so that next time my error will be less. It is the concept of learning by examples. So gradient descent, steepest gradient descent, and gradient descent with momentum and all, they all use this type of inductive learning. So up to this point, if anyone having any question, they can raise that question. After that I will talk about the other two types of learning. Yes. Inductive learning is used in both supervised and unsupervised learning, but majorly used in supervised learning, where it can be used for both classification and regression. But it mostly used in supervised learning, because in a dimensionality reduction or unsupervised learning, you whenever new feature is come, they are used. Suppose I give an example, but not much. Like you are having a lot of examples, and those examples having some certain categories of behavior. There is another set of sample that is having some different categories of behavior. So you are making some distribution. If I go into the probability space, so, or generative AI, so suppose you are taking some sample, from a particular distribution, it will having its own behavior. If I take some sample from some other distribution, they will have a different behavior. And obviously if you come up with a new sample, the sample, maybe if it is the closer to the mean of the first distribution or the second distribution, based on that I can group the new sample into a particular category. So unsupervised learning also, inductive learning can be used. Yeah. Okay, can you elaborate it more clarity? What? Here we learn from the data only. If I there is a strategy of rule based that I will come up with. No, that is a strategy I am going to explain next. That I do not. I want to frame a different name for it. Inductive learning, I would like to focus on only data, and if I want to use expert knowledge, you are talking about the expert knowledge. there I need to, in that case I need to first talk about the drawback of, suppose inductive learning, assume the inductive learning is only learning from the data, not rule. Labeled data, it is learning from the data only. Or unlabeled scenario also it may work, like in unsupervised learning, but it having a lot of data, from the data it is learning the pattern. Like in case of classification, like spam detection. So it has seen lot many spam mails and normal mails, and from that it get to know that if these are the words are there, it is spam. If these words are not there, it is not spam. No one is telling if that word is there, it is a spam. Based on seeing lot many spam mail natures and lot many normal email natures, it got to know that if those natures or words are there, it is spam. If those words are not there, it is not spam. No one has guided. No one has guided it. Solely from the data it get to know those things. Face recognition, learn facial patterns, and from that emotion detection and other things they do. If it is having those like lip is like up, then maybe happy, lip is down, then that person may be sad. So that type of pattern they learn only from the data, no expert. Handwritten digit recognition system learns from labeled digital images only. Now come to that question or suggestion, I would like to say, what is the drawback of inductive learning? First, capable of generalization to unseen data. It can work on unseen data very well. Works well on large data set. If you are having a very huge data set where statistical learning fails, it will work. It will better than rote learning because it can work on unlabeled data. Forms the foundation of modern machine learning, which we call deep learning. It is the foundation. Now, limitation is what? It requires a huge amount of data. Can overfit if the training data is poor. If the data is not enough, it may fail. Performance depends on the quality of the data and the features. No, unseen data means, I mean to say, the data which we use during training is called training data, and the data which we use during evaluation, that is called test data or unseen data. Like whatever we, suppose I am a teacher, whatever the problem I solve in the class and explain the solution, that is maybe training. And whatever in general we do not give the same exact problem in the examination, we give some different problem in the examination. That is the test data, and that data not seen by the student before, so that is a unseen data. So test data is a unseen data, and the test data also having an question, and question must come up with an answer. And in the classroom, whatever problem I have discussed, that was a question along with the explanation and the solution. So the training data, in case of supervised learning, training data is a labeled data where I have given the question, I have given the solution. In a test data unseen, I have given the question, the student is supposed to give the answer. That is the unseen data, means test data, and that is a training data, both are labeled. Now if I talk about unsupervised learning, you have a set of data based which you know what is the distribution of the data, what is the pattern of the data. Maybe that is a cluster of circles where all the data points are there. You may be having another circle where lot of the data point is there inside the circle. So if I that is that during training I said that if these features are there, it is like if if it is shape is like apple, if it is look like apple, if it is taste like apple, if it is color like apple, it is apple. If it is look like orange, taste like orange, texture like orange, it is orange. Now in the exam time I can give a particular ball to that student, a particular food to that student during examination, and ask check it whether it is similar to apple or orange. They need to see the color, they need to see the texture, they need to see the shape, they need to taste it, and they will say whether it is similar to apple or similar to orange. So unseen data and a seen data, there is a concept of training and testing. Unseen means test data. And it is applicable both in supervised and unsupervised learning. Animal and bird. Avian. Okay, very nice. Like, yeah, that is a very interesting question. So, that is an interesting question. So, suppose I have only one information about the animal, that someone having 2 legs, someone having 4 legs. So that feature is a single feature, univariate, and that feature having discrete value 2 or 4. In that case, something comes with 3 legs. In that case, you cannot make the judgment. Equiprobable. But if there are other feature, if you can add like what will be the length of that 4 legs, or like 4 leg having the cow having 4 leg having different length of those legs, whereas birds may not have that much of length of those legs. So if you along with that 2 and 4, if you the other information related to the leg, that will definitely guide us to a better judgment. But if it is just saying that 2 and 4, so there is one cluster where suppose there is one point, it is 2, there is one point, there is a 4, and there is a new point come 3. Now which class it belongs, you cannot decide. But along with the 2 and 4, if you add some another dimension, like it may be 2 comma 1, it may be 4 comma 5, and in between maybe 3 comma 1. So 3 comma 1 will be closer to 2 comma 1. So add up a new dimensionality, and then it will be become closer to one particular group, no? So am I able to clarify it? Huh. Hmm. No, yeah, that is yeah, we have to learn, we have to understand, but here we need to like make a call, and that call is based on whatever we have observed. So observation is there required. So the now I am talking about what you have asked earlier, that there are supposed to be certain set of rules in inductive learning. So as I am stating, suppose the inductive learning having no rules, it only learning from the data. What is its limitation? As it is solely learning from the data, if data is not enough, it cannot learn well. What, suppose I am a teacher of ML, I teach student ML courses and topics all well, but in an exam, the question comes in the exam that may be very different from what I have taught in the class. The student will not able to perform well, out of syllabus, or may not perform well. So that is why the learning I should have, as the student suppose learning only from the problems, so it should be dense, it should be high. And if we do not have a particular domain of problem, suppose in a mathematics I have taught everything, I have not taught integration. Now if the problem comes from integration, they cannot solve it. So this type of scenario, inductive learning will not work, and in that case we need to we need to higher version of the inductive learning, like you were talking about. Let me come up with that. That is the knowledge based learning, I can say. So knowledge based learning is what, or explanation based learning is what, where I am saying I am having a very few sample, and from that very few sample it may not be possible for me to learn. In that case I need to have an expert. So suppose I am a physicist. I am a physicist, and in that case, even if a physics problem comes to me, even if I have seen very less number of examples, then also as I am having a huge knowledge related to that physics domain, I can use my domain knowledge and I can come up with an answer. And based on, I am a medical expert. I am training with some data, but data is not enough. But with the data, I am also having the domain knowledge of medical science. In that case, I can use that domain knowledge and I can come up with an answer. So based on that, it is called the explainable learning. Now, how people is going to assure that I am having the domain knowledge? I need to give the explanation. So explainable AI comes into the picture. I went to the doctor. I am having some maybe the red eyes, sneezing, running noses. I went to the doctor and asked doctor, please treat me. Doctor said, okay, you're having cold. Take this levocetirizine, some antibiotic, azithromycin, and other painkiller, maybe paracetamol and all they given. I ask, how you can say that I am having a cold? He need to explain. So he is going to say that this virus come into your body. It is now it is going to stay for your body as long as he not dead or it not dead. So it is need to, that virus, the influenza is going to complete its life cycle. That time it is going to give you lot of pains, and for the pain relief you need to painkiller. That virus need to be killed, so you need to have an antibiotic. And obviously for levocetirizine it will take care of your nose and eyes. So this is what this he explains based on the domain knowledge. He knows what are the things, what has come to my body, what are the things it is going to affect, and what are the each of the component I can take care by different medicines. So that is why he is explaining. Like earlier the email was black box. If a mail comes to me, I say that mail is normal mail or spam mail. Now they are saying if a mail comes to me, they are going to say it is a spam mail due to these are the certain things are there based on which I judge that it is a spam mail. So that is the explanation based learning. Now explanation based learning having one limitation, like it works when the data is few, but it is having a limitation, like it is having a bias. Like you can say inductive bias kind of things it may be having. So it is the explainable learning. So if the data, so now you may ask me when to use the explanation based learning and when to use inductive learning. So if your data is very uncertain, suppose I need to check whether a particular email is spam or not. Suppose in that case there may be lot of uncertainty, there are lot of gray zone is there. It may look like a spam, not a spam. It may not look like a spam, it is a smell. But so when there is an uncertainty, you should read as much data as possible and come up with the idea of boundary, this class or that class. But suppose there is some thumb rule is there. That rule is not known to me, but there is a thumb rule is there. There is a rule. There is a function there. That function is not known to me. In that case, but the expert is there. I want to solve some physics problem. There is a formula is there for the answer. So x, y, y is a function of x. And that physics teacher or expert know that function. So even if you are having a few data, then also it can interpret what the possible y value. So in that case, when most of the things like in this example, inductive learning, like I have seen many examples, so I learn the pattern. And it is used when uncertainty is there, noise is there. Explanation based learning means I understood why this example works, so I apply it generally. I am a doctor, you come to me with these symptoms, running nose, sneezing, red eyes. I understood this example. and so I apply, I provide you the corresponding medicines. Whereas inductive, I have seen these many scenarios. So when there is a fixed outcome can be there, uncertainty is less, you should go with the explanation based learning. And other things like where it can be used, a robot learning how to stack blocks correctly by reasoning about the physics rules. So there is a absolute way of stacking all the blocks. There is no uncertainty. There is a definitely there is a unique solution is there. There is always a base solution there to stack all the blocks. Now who knows is best? The physics person. The person who knows the physics rules, they know that these are the way they can be correctly stacked. So in that case, I should go with the explainable learning. A medical diagnostic system learning rules from a single correctly diagnostic case using medical uses. Theorem proving. But if there is an uncertainty is there, this will not work. So there is no absolute answer. In case of stacking the blocks, there is an absolute answer is there. This is the best way of stacking. But suppose some scenarios the outcome is fuzzy, outcome is probabilistic, uncertain. In that case, you should solely rely on data, and if the data is less, it can mislead. Advantage: learn effectively from very few samples, produces clear interpretable rules, use domain knowledge to improve learning quality. Limitations: strongly depend on accurate prior knowledge, so inductive bias will be there. I know this, I will not really change my ideology or thinking until I come up with a lot many evidences that is going to trigger me to change my decision. Not suitable when domain knowledge is incomplete. If I am not having enough domain knowledge, I cannot apply. Less effective in noisy and uncertain environment, which I just discussed. So suppose you went to the doctor with some symptoms that is not familiar with that doctor. So in that case, doctor should not make the call, no? Because it can lead to more complications. So if I talk about all these methods in a very simple terms, so statistical learning is data driven. From the data we can know the probability, we can know the stat, we can make the call. But it is not feasible if the data it require huge amount of data, and sometime with huge amount of data it become computationally not efficient. Rote learning, it is memory driven, it has memory, it has a lookup table kind of thing, and if it is matches with some input, the corresponding output it will provide. Advice based learning, I was talking about two type of learning I was talking about, by taking advices and by the expert. Inductive learning is the example based learning, and explanation based learning is the knowledge driven learning. When to use each method? So use statistical method for big data. If you having huge data, you can use statistical method, but also take care whether it is statistically computationally intensive or not. Use rote learning for repeated task. You know the same, you know what type of input it may come to me. So accordingly, like in menu, e-commerce site or any feedback, there is a menu. They know these are the exact type of question customer may ask, and these are the exact solution I need to give to the customer. So where there is a repeated similar task is there, we should use rote learning. Use advice based learning for domain knowledge. If you have like someone like very good at that domain, you should use that domain knowledge and apply advice based learning. If you do not have the expert, but you want your model to work well in uncertainty scenario for unseen sample, you should go with inductive learning, where you know there is one base solution or a set of base solutions are there, and you know those experts which can give the base solutions. then even if you have a few sample, you can go with the explanation based learning, where the branch is explainable AI. So which learning method is more scalable? If I ask you, which learning method is most scalable? That means if the data increases, it will not fall apart. Inductive learning, na? So inductive learning is scalable. Can multiple learning methods be combined? Yes, definitely they can be combined. How do modern AI system integrate learning paradigm? Modern AI में कोई example they combine where? Example based, right? Example based, they having the example as well as they are having the domain expertise and all the things are there. Yeah, rightly pointed. Any other? Okay. So I'm not coming into this. So summary in this class: learning methods from foundation of AI. What are the method was there? Broadly scaled 6 type of method was there to learn, which can be combined to solve complex problems. Different methods serve different purposes, which we have like categorizedly discussed. Combining methods often improve performance. So many times we need to combine multiple methods to come up with a better performance. So now I am open to the questions. So if anyone having any questions, they can obviously ask me. Fraud detection means email spam kind of things you were talking about. So yeah, in that case we should go with the inductive method. In the inductive method I would suggest better to go with or maybe a combined method with the inductive as well as the explainable based learning, where we can use the deep learning methods. So in that domain you can use deep neural network and all, or more advanced models you can use. That is the most easiest, that is the simplest solution I can talk about, but it may not be efficient in complex scenario. So like initially I said that if the mail having some slang words, if the mail having some prize money and all, if you can put like in Google or somewhere, if it is encounter some slang words, if you encounter some words which is prize money and all, and if you encounter some email which is coming from a different domain, maybe from other country and all, in that case I can flag it as a spam. You can do that. So no, machine can also do the same thing, na? So like your sentence, if I talk about the natural language processing and all, each word can be mapped into each word is a feature, na? So if that now ML learns with the features. So in your case, if that feature is on, when it is a machine learning model, an email comes. So every word, in a simplest word I am trying to explain, this is suppose an door that is controlled by ML model. Now this mail comes to you, the mail containing multiple words, each word is a feature that will be decoded. Now already that ML models seen those features which are on for spam mails. So if prize money, that word is there, or other some terms or words are there, it has already, ML model has seen that maybe if you know probability, suppose I don't have that marker. So suppose you are having 10 spam mail, and in those 10 spam mails, 8 spam mail having the word prize money, 2 spam mail not having the prize money. So what is the probability that spam mail having that word? 4 by 5? 4 by 5? Sorry, 4 by 5 means 80%. So if a new email comes to me having that word, what will be your judgment? It is a spam. So this is the simplest way email works. If I follow the Bernoulli distribution and consider the features are discrete. However, real world scenario are a lot more complex. I just show you the most simplest way it can be done. If you assume there is a single feature and the features are univariate and follows a Bernoulli distribution. Any other question? Did you get it? Okay. So any other question or query or perception? Well, if there is any question comes later also, like I may be coming again. I may be possibly Sunday. So if you have any doubt in, you can note it down and you can ask me that day also. There is no issue. Okay. 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 Can you phrase the question again? No, you can sit. Please sit. Okay. Okay. Let me rephrase the question again. So basically, if I have to rephrase the question, I would better go with the wordings like this. We mostly use dot products in a machine learning, and we use less number of time cross products. However, do we have the concept of covariance matrix? So dot product means what? Dot product is mostly give us a scalar value. End of the day, real world, suppose you need to make a guess, make an opinion, 0 or 1 or maybe some value which is higher or lower than the threshold. So that is why we use dot product. Like A is a vector, B is a vector, A dot B is a AB cos theta. And many a times we need to check whether the features are, sometimes we need to check whether the features are independent or not. Naive Bayes classifier, which has a strict condition that the features need to be independent. In that case, how you can check two features are independent or not? Suppose the first feature is A, second feature is B. A dot B is AB cos theta. If AB cos theta is 90 degree, in that case it will be 0. So if you take the dot product of the X and Y, and if you get output 0, that means A feature and the B feature are independent, and then certain rules can be applied, else it cannot be applied. So due to that reason, so dot products leads to a scalar value, and dot products check for the orthonormality and orthogonality. So that is why we majorly use dot product, but cross products are also used. Like if you look into the covariance matrix, variance we know, no? How much value is spreading with respect to mean. Now say if there are two features are there, 1, 2. So how two features are interrelated with each other? How one feature is varying with respect to other feature? So suppose here the height of a person is a feature. Maybe average Indian having a height of 160 centimeter. But a few Indian having the height of 190 till centimeter, and some Indian maybe height till 130. So in that case, the spread is what? From 190 to 160, that is the spread, or from mean is 150, that 40, 150 to, sorry, I should say 160, 160 to 190, that is a 30 unit is the spread, or maybe 160 to 130, there is a 30 is the spread. So that is how the value is spreading. Now maybe there is another parameter is the weight of a person, and weight may be varying maybe from suppose from 70 kg to 50 kg, and mean is 60 kg, then the weight is varying 10 unit, positive or negative. So in that case, if I ask you how weight is, now for each person you are having a weight, you are having a height, and if I ask how weight is varying with respect to weight, or how weight is varying with respect to height, in that case one feature having a variance with respect to other feature, that is called covariance. And in a covariance matrix you can see we explicitly use a cross product. So x minus mu transpose. So we use cross product, but there are certain scenarios where we need to know the all combinations. Because cross product क्या होता है? Matrix multiplication होता है where we go out the outer derivative. So where we check out all the combination of the component of the matrix. So it are obviously used, but maybe not as much as dot product. Okay. Any other question? Is it clear? Okay. So if if anyone having any question, they can note it down. They can ask me later as well to me. And okay, I also will provide my email ID and a phone number so they can reach me also. Yeah, there is no issue providing it. I just put the email ID and contact number and I can provide so people can reach me. Okay, so shall we conclude here? Okay, thank you everyone.
Thank you, sir, for a wonderful session. Sir, your clarity made a strong impact on us. We are truly honored to have learned from you. Thank you very much, sir.
Thank you. It was a very interactive session.
Launch is ready. You can go and take your launch. And the next session will start sharp 3 p.m. Thank you.